Hello. In this video, I'm going to be working through the CodeCheck Python exercises for the assignment Week 10 List Algorithms. Let's go full screen. In gymnastics and diving, a competitor's total score, which is comprised of the scores from 8 judges, is computed by removing the highest and lowest score and then summing the remaining 6 scores. Use the functions from section 6.2.7, that must be from a textbook that we're not reading, to compute a competitor's total score from a list of scores awarded by the 8 judges. Well, we don't know the functions from section 6.2.7 because we're not using the textbook, so we're going to have to make it up as we go along. So we are removing the highest and lowest and then summing the remaining 6. So in previous videos, we worked through in detail some maxing and minning and deleting of indices. So let's try to use some of those skills. So let's call scores at something is going to be del. And since we're just doing it twice, we can probably, we could just do 2 lines of code with repetition, or we could do for I in range 2, which will go 0, 1, and we don't really care about I, so we can just do under I or dunder I. So we'll do underscore or just underscore. We don't even need the I. For underscore in range I, we can del, and actually we should be able to just do that on the same line because it's just a single line of code. Del scores at something, and what is that something going to be? The something is going to be the scores.index of scores of max scores. So delete the thing at the index, which is scores, asking for the index of the value, and that value is derived from the current maximum of scores. So the first time we do it in the loop, it will be the first maximum, the most maximum, then that one will get deleted, and the second time we call it, it will be the next maximum, or the second largest. Then we will also do the same for min, and so actually a clever thing we could do here would be for underscore in range 2, we could also do a nested loop. So for underscore in range 2, and then for function underscore name, I'm just going to call it, in the list, which I will pass in the max function and the min function, then I will just I will delete the most maximum and the most minimum, and then I will do that again, and I will remove the most maximum and the most minimum again. So that would be a way to remove those, I believe. And then the total score should be the sum of the remaining 6 scores, and I do think there is just a sum function which sums up a list in Python. So I'm not going to go do every possible iteration of this problem because you could solve it in so many different ways. But let's just see if we can use sum of scores, which we've now edited to remove the two largest and 2 smallest here. And we have an issue because there's no colon at the end of this for loop. How did I detect that so quickly? It's pointing out this little caret to there. We're expecting a colon. So it's literally telling me the error in the error message. And now we messed up. So why did we mess up? Computed by removing the highest and lowest score and then summing the remaining 6 scores. I wonder if they'll let us print to debug. Yeah, they're letting us print. So we're left with highest and lowest score, not the highest 2 and lowest 2. So just a misreading of the problem. It means we don't actually need this, this nested for loop. We just need a single for loop, and now our tabbing is out of whack. So this is actually double tabbed. I'm going to delete and tab over a single time. And we're still messed up. So we removed the highest score and the lowest score. And I'm calling max every single time, so I actually should call function name of scores. And still wrong, so 55.7, Is it because, maybe it's because it's because of the printing of the scores, or because we're like, they don't like that we didn't use the functions that were given in the textbook? No, okay, it was just the extra printing, because printing was how they were grading us. So if we print superfluous things, that was illegal. Okay, so probably lots of ways to do this. We could do all of this like built-in stuff of index and, max and min. We could write our own functions for those, but why reinvent the wheel when Python has that stuff built in? Complete the following function that builds and returns a string containing this sentence constructed from a list of words with the individual words separated by a single blank space. For example, the words list contains the strings the itsy bitsy spider. Yeah, now I'm wondering, because this is about loop algorithms, if we were a bit hasty in using these built-ins, because we were supposed to be using loops to solve this problem. So I could show how to build this using a loop instead of the max and min functions, but maybe that'll be an exercise for the watcher instead of something I'll show. But comment if you would prefer to see that in more detail. So for this one, we just need to add spaces. So I think in a previous video, we found the shortcut for adding spaces to something. We just do the empty string or whatever we want to join with. So if we want to join with a space, we just put a space in here, dot join, and then we pass in as the argument to the join function the collection that we want the joined things to be grabbed from, which is just literally the words list. So I believe that will be correct. Nope, because we didn't return it. Classic mistake of a function is computing something and saying space.join words, but not returning it. So we're going to return space.join words, and that should give us the answer. But they wanted us to do a loop algorithm. So in the spirit of that, let's go in a little more detail. So yeah, really, they just want us to use probably the accumulator pattern, where we accumulate the result one by using some kind of loop. So we'll start with the sentence, which we can't edit up there. So let's do, we'll call it sent, and sent is going to be equal to nothing. And then for word in words, we will sent plus equals. We will add to the end of sent. We will concatenate to sentence the current word, but we'll also need to concatenate a space. So we could do that in a couple ways. We could do space plus word, or we could do the other way to do this would be sent plus equals. We do like this, sent plus equals an F string. So an F string is like this. So F just says format, just says I'm going to put stuff in here that is coming from a variable. So I could say space, curly braces also get ignored, and then word will be turned into its value instead of word. So the F won't appear, the curly braces won't appear, and the word won't appear, but the word of whatever the value of the variable word is will appear instead. Oh, and that of course is going to pass because we're just returning what we did before, but we should just return sent in this case. And we had a mistake, and why is that? Probably something to do with extra spaces. Yeah, so you see there, if we just have word, you'll notice there's a hidden space that we're adding after that. And so the key here is with an algorithm that does this, we don't want to add the word and then a space every time. We want to add a space only when we have a new word being added. So like we need to add the space before words instead of after words. So what would that look like? Well, actually this one we're doing space word, actual and expected. We're actually doing, looks like we have, no, we do have space word. We have space word. Huh, that's weird. I guess we have space word, it's kind of unclear whether we have a space after. We should have a space before here, but on that one it doesn't. So an easy way we could just call sent.trim to clean up our spaces after the fact. I believe that would work. Trim is not a function, so I think maybe that's like trim. It might be a global function, like len sent, or it might be like from the str kind of library, string.trim, like that. It's just trim maybe. Let's see. Python trim string just means to remove the white spaces from it, like tabs and spaces. Strip, of course it's strip. Why would it be strip? So we just call sent.strip. So this is the shortcut that will probably work. Yes, it worked, but the other thing we could do is just be a little bit more careful about adding spaces. So we actually just, like, an easy way to do this, I guess, would be for word in words, if word is not empty. So if we're empty, we don't want to lead with a space. So if the string starts at here, we don't want to lead with the space. Many different ways we could kind of handle not doing that, but one would just be an if statement. If not sent, so if not sent means actually if len of sent is, not equal to 0, so, or is equal to 0. So if not sent means this, I'm asking, is the string empty? So are there no characters in the string? If not sent, so if the string is empty, then don't add a space. If so, sent plus equals word, and then else sent plus equals space word. So that would be a way to pass. And then the other way, you can see we have a little bit of duplication here. We could actually just do if sent. So if there is already some letters in the word, then we'll add our space. And then instead of doing else, we'll just say either way, go ahead and just add the word itself. Because we're always going to be adding the word. That would be a little bit more concise. So there we go. Complete the following program that removes all negative numbers from a list of values. All right, so the functional approach for this would be very easy because there's a filtering function in Python, but we'll not use that at first. We'll try to just remove all negative numbers. So let's see, we could go through all the indices. We could get the value. If it's negative, then we could delete it. That would be one way to do this. So we could say for index in range len values, add a colon, new line. So for each of the indices in the thing, we get the value is equal to the values at index. Now we have the value stored, the current value. If value is less than 0, so it's negative, then we do something, and that thing that we do is del at values at index. The way to shorten this would also be if values at index is itself is less than 0 without creating another variable, then del values at index, and that's going to delete in place. Use a while loop. They got us. Okay, so we're going to have to go through this a different way. Why did they want us to use a while loop? While, okay, fine. We could start at the end or the beginning, it doesn't really matter. Index equals 0, while, we're still going to need len values. We'll say while index is less than len values, so while we're not out of bounds, look and delete. Is that going to be allowed? Nope, we never increment. That's why I don't use while loops. Whoops. So then we need to index plus equals 1. And we passed. No, we failed. Why did we fail? Let's try again. That was weird. I think we're fine. So they're going to make us use a while loop. But how would I really do this? I would say values equals filter values like that. And I would have to turn it back into a list. So I would wrap it in a list, or I would do x for x in filter values. Like x for x. Like that. And then filter expects to, so filter values, you need to actually pass a condition on which to filter. So values is the second argument, and then the first argument is lambda, or some function name, lambda x. So, well, x is a bit confusing since we've already used x, so we'll say y. So for a given value of the values y, if that y is less than 0, then we will, I think the filter is supposed to say keep if. So keep if greater than 0, greater than or equal to 0, I believe. Keep if. Yeah, so filter, but keep if greater than or equal to 0 on that, and we'll get the same answer. And we tricked it. I think we tricked it by having a while loop. Yeah, by having a while loop and a comment. So that was a little sneaky way. It's just literally looking, it's doing like a string search for the word while in our code, and we tricked it by having it in a comment. But that's not what you're supposed to do. Walk through the following code that swaps two elements in a list. Oh, we just got here. This is a classic, using a temp variable to exchange two values in a list. Okay, start. So I is 1, j is 2, a at 0 is 3. Good swap. Temp is a at I. So a at I is 1. Wait, no, a at I is 1. A at I is 9, so temp is going to be 9, right? Yep. Now a at 1 equals a at j is 2, that would be 6, so a at I, which is 1, equals a at j, which is 6. A at j, this is even hard for me to follow. Like, why are they doing this? Oh, bad swap, good swap, bad swap. Okay. A at j equals temp. Temp was 9. We have it over here. So 9. A at 1 equals a at j. So a at 1 equals a at j. J is 2, which is 6. Nope. This is what they're trying to trap me on. A at I, which is 1, is equal to 9, equals a at j, which is 2. What am I missing here? Oh, it's 9. We're later in the code. They're doing a second swap. They're not like redoing the swap. Oh, I have to start over now. That was an accident. temp is 9. I'm just going to look at the table. I should be reading the code like I was before. A at j, A at I is A at j is 2, 6. A at j. See, I don't think this is really helping me understand this. I wonder what viewers are thinking about that. A at j is equal to temp 9. Bad swap. Now A at 2 has been changed to 9, so A at I equals 9. Yeah. And then A at j equals A at I, which has now been changed to 9. So we've already overwritten it, and so it's not actually changing it as intended. That's what they're trying to show. Modify the algorithm in section 6.3.3, which we don't know about, and the code below so that it prints all positive values of a list separated by commas. Okay, values are given for I in rangeLen values, very common pattern for going through the indices of a list. If I greater than 0, print space pipe space end equals nothing. Okay, so we're not doing a new line on the print. That's what the end equals nothing means. Print values at I nothing. So we should be getting like 1 space pipe space minus 2 space pipe space like that, and we want it to instead be commas. So it's just, is it not just separated by like that? Just remove the spaces in the pipe. See if that works. Actual expected with prints all positive values. Yeah. So print comma. Do I just need to tab this over so it's only print the value if it's positive? If I is positive. If I is greater than 0. Yeah, why would they put the comma part in there? And so we're only going to put the comma, print the value, and then only print the comma if, I would say like, if, ooh, that's tricky because we're not accumulating it in a variable. Well, I would just use join for one thing because it's a shortcut for this. Like what I would really do is I would print comma dot join values. That's what I would really do. Where comma dot join filter filter lambda x is greater than 0, comma values. That's what I would do. Forget all of this. Expected string instance int found. For a particular character. What? String.join filter lambda x on values. Too much complexity here. But this is, I think they're not going to want us to do this, but I'm still going to do it anyway because I want to. So values with no negative is list filter values with, so keep if positive equals lambda num colon num is greater than 0. So keep if positive returns true if the number that comes in is positive. So we're going to filter with keep is positive on values, filter it, turn it back into a list. Then we will print comma dot join. I thought that's what we just did. Comma dot join values with no neg, like that. What's the issue here? Oh, we just need to comment that out. What's the issue? Sequence item 0, expected string instance. Is it just because they didn't want us to modify the last print statement? How is that an int? Oh, wait, no. As string should just be, let's try empty string dot join. What is this? Let's try to Google this error. Python join. An iterable containing only strings. Oh, but your list or tuple contains at least one integer. So we actually need to convert to the strings that are in there to integers. So if, yeah, that's keep if positive, and then turn to, or actually we don't, turn to int, which converts it into an int, is just going to be the int function. So the function is going to be turn to int equals int, or turn to string equals the function stir, which is built into Python. So we're just going to say the parts equals map turn to string on not values but filter values, where we're filtering by keep if pos. And then we will just join parts with comma, print as stir. Come on. Oh, no spaces. Expected spaces. Let's add a space. There we go. Okay. So again, probably not how they want us to do this, but this could be done all in one line, because we can take num greater than 0 could be as small as like n, and turn to string could be as small as stir, and then we can just directly print, place this into here, and then we can just place this into here, and then we literally only need that line. Yeah, so that's as small as it can be, but that's super unreadable and also probably not what they want us to do. So what they really want us to do is modify the algorithm. So let's go back to, I'm going to copy this because I'm proud of it, reset, comment that out. So what they want us to do is boring, comma, space, and they wanted us to tab this over. This is going to be wrong, but let's run it. So we're pretty close. If I is greater than 0, so we wanted to do, instead of I, if the value's at I. So if value's at I, why is this tabbing so weird? If value's at I is positive, then we'll print values at I. And we will print a comma, but I think we're still going to have like a too many trailing commas or something like that. Yeah, trailing comma. So how do we avoid the trailing comma? We could say, I guess we could say like, yeah, if I is greater than 0, they had kind of already hinted at that for us. So if I is greater than 0, then print the comma. So that means if we're on the first one, we're not going to lead with a comma, but if we're on anything but the first one, so anything greater than the first one, then we'll add the comma as well. Nope, that's wrong, because we want to add the comma on everything but the last one. So if I is less than len values, maybe that's closer. Still wrong. So we need to only also do that. See, we're printing extra commas here and extra spaces because we're printing commas even if we didn't add the number because it was negative. So you have to tab that whole thing over inside the if statement. And still wrong, because we don't want to do this on len values minus 1, which is a valid index. We want to do it on everything but len values minus 1. So if I is less than len values minus 1, finally, still failing. Okay, so yeah, if I is less than len values minus 1, we're still printing when there's just 18 is positive. We're still printing so if I is 0, 0 less is 0 less than len values, which is 1 minus 1, is 0 less than 0, then that should fail. Len values is 1. Len values minus 1 is 0. Is 0 less than 0? No. But I is 1 here. So is 1 less than len values? Yeah, this would be so much easier with functional approach. Is it so simple? If the we don't know if it's the last, we don't know if it's going to be the last thing. So I guess we should add it when we're adding a new one. We're adding a new actual number. So like here, we should add a comma before it only if something is true. And that if something is true is if we've previously printed something. So we're going to need a flag for that maybe. Like, this is so kind of hacky, but have printed something is false. This is a hack people do when they want to do things like this. And we're just going to flip this flag and then check the flag. It's very weird and hacky, but basically, have we printed something by default? No. And so if we, if if have printed something, then we're going to print a comma space and then our value. Otherwise, we'll print our value and we will now, regardless of the situation, have printed something is true. Or if we want to add a if guard, which is unnecessary, we could say if not have printed something. If we have not yet printed something, then set our flag to have we printed something as true. And now that will be correct. So very, very ugly, personally, in my opinion, compared to this one, which with a little bit more parsing out of the different function names and things can be pretty readable. And this can be as concise as just one line. So that concludes this lesson. Thank you for watching.